In this example, we have a Carnot engine on the left where we're transferring heat. We're given that the high temperature and the low temperature are the same as the reservoir, so ideal Carnot process. And we want to know if this overall process is possible. And the way we would do that would be determine the entropy change for the overall process. So first, let's just look at the left side, the heat engine. And for Carnot cycle, delta S is going to be 0. And so that means delta S for the high temperature plus delta S for the low temperature, the cold, is 0. So doing this for the engine, we're adding 200, and that is at a temperature of 400 Kelvin. And then we're removing a value that we need to determine. So we'll call that QC. And that's at a temperature of 300 Kelvin. For a cycle, that has to be equal 0. So that means we can solve for QC. And that is minus 150. And these are kilojoules. Of course, they would be kilojoules per some time, but we're just going to work on basis, say, of 1 second or 1 minute. If we have QC, we can use the first law to determine W, namely QC plus QH plus W, where this is a balance around the heat engine, would equal 0, minus 150 plus 200 plus W equals 0. So W equals minus 50 kilojoules. That's how much we're removing from the heat engine. That's how much we're adding to the heat pump. So let's make this so it's a little cleaner here. So I can put this as 50 kilojoules. Well, if I do an energy balance on the heat pump, again, first law says the total energy has to be 0. So we're transferring out 75, we're adding 50 as work. This must be 25 kilojoules to satisfy the first law. Well, now we can calculate the entropy change. We've calculated the entropy change for the energy being transferred from 400 and added to 300 Kelvin. That's the same calculation that we did here. So now we can do a calculation for QH, let's call that prime for the heat pump, over TH, where now TH, let's call that prime for the right side, the heat pump, plus QC prime over TC prime. If that's greater than 0, then the process is theoretically possible. Well, the QH, so we're going to do a balance on the reservoir. So now this QH is a positive number being added to the reservoir, so 75 kilojoules over 500 Kelvin. And then we're removing 25 from the low temperature reservoir. And we want to calculate what these numbers are. So the first 0.15 minus 0.083, 0.067 kilojoules per kilogram. That's entropy units. Delta S greater than 0 for an entire process. Therefore, it's possible. Doesn't mean we can do it, but it means at least theoretically it's possible.